here is just kind of a review of normal cell growth. I'm not expecting you to know all the divisions of the mitosis, okay? I basically want you to understand there's a G1, there's an S, a G2, and a mitosis. And then I want you to understand there's a fifth phase that's called a resting phase, also called G0. So kind of cutting to the chase. On G1, okay, sometimes that's also called first growth. This is just when the cell's basically getting ready to divide, okay? Then we go into synthesis. That's the next step. Synthesis is whenever that DNA is getting replicated, okay, and the cell's becoming duplicated. Then we have G2, which is the second growth, or GAP2. This is whenever we're preparing for division, Then mitosis is when we have the actual cellular division. That's when we get the two new daughter cells, okay? And cells go through this cycle, and they can also go into an active cycle, or they can fall out into the fifth phase, which is G0, or the cell resting phase. This is when a cell temporarily leaves the cycle, and it's just waiting to be activated again. So that during this time, in the G0 phase, the cells are not multiplying, okay? The amount of time that's required for any given population of cells to complete the cell cycle depends on what type of tissue is involved. Some of our tissues grow faster than others. These are now, we talked about characteristics of benign tumors and malignant tumors. These are characteristics of malignant cells, okay? The first item up here says that loss of regulation of the incidence of mitosis. What that means is that cancer cells just keep dividing. They have an ongoing cell division, and so they just continue to grow. A common misperception is that malignant cells grow faster. It isn't that they grow faster in the sense that they grow more rapidly, but they just continue to grow. They don't go into a resting phase. They just continue to replicate. They just keep going. They're like the Energizer bunny, so to speak, okay? Loss of specialization and differentiation. All the cells in our body are in our body to do a specific. What happens with cancer cells or malignant cells is they don't perform the typical cycle. Instead, they become more undifferentiated. We talked about loss of contact inhibition. They also have something called a progressive acquisition of cancerous phenotype, which means that the mutation is sequential, with each mutation becoming more deviant than the previous one. They also seem to almost develop an immortality in the sense that they just keep growing and do not seem to die like normal cells that have a defined lifespan. Malignant cells exhibit irreversibility. In other words, once they become a cell, they don't go back to not being a malignant cell. They also have the ability to transplant themselves, transplantability, which is another way of talking about metastasis. And we just talked about that in the slide before. They also have unique abilities to promote their own survival. That cancer cell, that malignant cell, is only interested in themselves. They could care less about the person that they are using as their host. It's all about themselves. They're a me kind of cell. So some things they can do is they can create their own blood supply. They can create the connective tissue to support the tumor, to divert nutrition away from healthy cells. They can set up ectopic sites or distant sites in order to produce hormones that they need. So they can do all kinds of things to protect themselves and help themselves grow. There are two main theories of carcinogenesis. The first is a defect in cell, and what that means is that normal cells have a specific purpose and they grow at a specific rate. They respond to natural hemostatic balances in our body. However, malignant cells, they don't do any of that. They just continue to replicate continuously. They could care less whether or not we need them. They also can be very, what we call haphazard in their reproduction. And so as a result, they can produce more than 2 daughter cells at the time of mitosis. A normal cell is going to divide into 2 daughter cells. A malignant cell might produce 4 cells. So as a result, they can just kind of do a pyramid where they just grow more and more cells by using the pyramid status. Something we refer to as doubling time, you'll hear that said. When we talk about doubling time, what we're just saying there is that's the amount of time it takes for a tumor to double in size. The second theory of carcinogenesis has to do with there being a defect in cell differentiation. Normally, our cells start out as stem cells, and then at that point they're undifferentiated, and then they become differentiated or specialized. Once they become differentiated or specialized so that they're taking care of a specific function in the body, they don't go back to being undifferentiated, okay? Once they say, I'm going to be a skin cell, they don't all of a sudden say, oh, I didn't like being a skin cell. I'm going to go back to being a stem cell because I might want to become a liver cell next. So once they differentiate and they get their function, they stick with that for normal cells. But whenever cancer happens, then that's when the genes that control this proliferation and differentiation malfunction. Typically, we have something that are called proto-oncogenes. These are the normal cellular genes that promote our growth of cells and serve as a lock. So what I mean by that is that that stem cell is told to grow by the proto-oncogene, okay? And it says we need more skin cells. So that cell grows and it differentiates or becomes specialized and it becomes a skin cell. And then once it's a skin cell, it's a skin cell. It doesn't become something else, okay? But what can happen with this defect in cell differentiation is we will see the cell kind of reflect back into its fetal state where it produces proteins that are associated with embryonic and fetal stages of life. And these are called oncofetal antigens. I'm going to spell that. ONCOFETAL antigens. I want you to think of this as a broken lock, okay? So that normal cell that became a skin cell is going to be locked into being a skin cell. But with this defect in cell differentiation, that lock is broken. So even though that cell became maybe a skin cell, these this break in the cell differentiation in the creation of these oncofetal antigens lets that cell become undifferentiated again, okay? The other thing that happens is that we can have tumor suppressor genes that become inactive. Normally, we have tumor suppressive genes going around in our body, and they're helping to say, no tumors here, no tumors here. But when we have a defect in cell differentiation, what can happen is that those tumor suppressor genes have mutations that make them ineffective, okay? When we talk about the development of cancer, we're going to talk about 3 different stages. First off, we have initiation. All that initiation is that there's a damage to that cell's DNA, and it's permanent, okay? So we have a permanent mutation. It could be, it's the result of exposure to some type of a carcinogen. There could be an inborn genetic error, very rarely, about 5% of the time, but typically you're going to see some type of an exposure to some type of a carcinogen, such as a chemical, radiation, or viral agent, okay? So we've got this damage. Something has happened to that cell and it's damaged, okay? But that in and of itself, with that one cell being damaged, doesn't result in cancer. What has to happen next is over a period of time, we go into this promotion phase. This is when we have continued or repeated exposure to the carcinogen. And as we have that continued or repeated exposure, then those mutated cells begin to proliferate, okay? We can change things by taking away the promoting agent. For example, probably the most obvious one is smoking. So let's say we have damage to some lung cells, okay, and we continue to smoke. We're continuing to just pile that carcinogen on, okay? Let's say we stop smoking. We've taken that carcinogen away. We can't get rid of what's already happened. We can't make that damaged cell be all better. But what we can do is we can stop throwing more and more carcinogen on so we don't get that proliferation of the altered or mutated cells. When we have initiation or that initial damage through promotion to when we can finally see some clinical evidence of the cancer, we call that a latent period. In order for us to see some evidence of the cancer, typically we can palpate a tumor at about 1 centimeter or centimeter. I think you say centimeter. By centimeter, or sometimes a centimeter. And with our best diagnostic tools that we have, we can detect about 0.5 centimeters or centimeters, okay? Then we have progression. Progression is whenever we have further changes that are acquired during the cell replication and then develop into cancer. And at the final stage, we see an increased growth rate of the tumor. We see them become increasingly invasive, and we see metastasis. I'm going to talk a little bit about, oops, I think I might have skipped a slide. Hold on a second. Let me go back. I did. These are risk factors that impact the risk of developing cancer. Age is probably one of the biggest ones there. Remember that 77% of all cancers are diagnosed in individuals who are 55 or older. And that's because, from a scientific standpoint, we know it takes about 5 cycles of genetic mutation to permanent damage to the affected cells. Long-term exposure to the carcinogens is really what kind of really pushes that along. We know that different types of cancer are more common in different genders. We also know that poverty results in an inadequate access to health care, reduction in preventative screening. We also see diet and stress levels that are not all that preventative. So we'll see a diet that may go more along with the development of cancer. Whenever we have high levels of stress, we have a continuous production of hormones. And when we have a continuous production of hormones, we'll go ahead and produce epinephrine, and over time we get what's called systemic fatigue, and then that will ultimately impair our immunological surveillance and impacts our immune system. We talked a little bit about sun exposure. I'm not going to talk about all of them, but those are some common risk factors. The immune system itself, we've talked about that in the previous section earlier in the semester. So we know that the immune system plays a role in recognizing and taking care of tumors.